Hi everyone and welcome back to my channel. In previous videos I spoke about how to calculate the maximum demand and the differences between maximum demand and the maximum demand after diversity. In this video I thought it would be helpful to talk about ways that we can reduce the maximum demand calculation. So if you've ever been in a situation where you're working on a project and the specification keeps changing and more loads keep getting added to the project and you're worried about the effect that that's going to have on the maximum demand, in this video I'm going to share some tips with you on how to reduce the calculation when working in accordance with the IET's on-site guide. So the first tip that I'm going to give you is to think about how many circuits that you need, because the number of circuits will affect the maximum demand calculation when you're working it out in accordance with the on-site guide. Now obviously it's important to think about how many circuits we need to make sure that circuits aren't overloaded or to minimise inconvenience in the event of a fault. But I think it's sometimes possible to add more circuits than we need, and I've come across small studio flats with 10, 11, 12 circuits in it, and that really has a big effect on the maximum demand. So have a think about how many circuits that you need from the start of the project and think about the maximum demand. So the next thing to bear in mind is cooker switches. So one way of reducing the maximum demand is by not having a cooker switch that incorporates a socket, because that's going to save us 5 amps. Now I think that most customers would probably want to have a double socket next to where the cooker switch is, provided that there's not enough room above the worktop. And the interesting thing is, even if we add a double socket to the ring circuit in the kitchen, that wouldn't affect the maximum demand for that circuit, but having a cooker switch that incorporates a socket outlet, that does affect the maximum demand because it adds that 5 amps to the cooker circuit. So it's just a tip to bear in mind there, that if we have a cooker switch that doesn't include a socket, then that's going to save us 5 amps. Now that takes us on to ring socket circuits. Now the thing with ring circuits is that you can typically have a 2.5mm circuit protected by a 32 amp circuit breaker, which is rated at higher than what the cable is. The reason that we're allowed to do this is that because each leg of the ring is not expected to carry more than 20 amps. Now that is provided that the circuit is wired in accordance with Appendix 15 of BS 7671. So for example, we must make sure that the number of spurs don't outnumber the number of original outlets on the ring. We can't have appliances greater than 2 kilowatts, for example. So provided that the circuit is installed in accordance with Appendix 15, we can have that circuit protected by a 32 amp breaker. So my tip here is, if you've ever been in a situation where a customer asks you at the last minute to add a socket in the cupboard under the stairs, it's really easy in that situation to just add a separate radial circuit, but that is going to add 16 amps to the maximum demand calculation. But if you add a socket to the ring circuit, then that won't add to the maximum demand calculation. So as I say, the caveat to that is to make sure that the circuit is wired in accordance with Appendix 15, that it's installed in accordance with the on-site guide, so we can't exceed the number of sockets for 100 metre square area. But if we do that, we can add sockets to that rather than adding additional radial circuits for individual sockets. Now you may be thinking, well, what's the difference? Because the customer is going to plug the same thing into it. The difference is that how the calculation works out when you calculate it in accordance with the on-site guide. So the next thing is lighting. Now in a previous video I mentioned that if you have pendant light fittings, the usual thing to do is to allow 100 watts per light fitting. But if you know the rating of each fitting in watts, we can calculate the load exactly and then calculate the design current, and that makes a really big difference when calculating the maximum demand for a lighting circuit, even before we've applied diversity to the circuit. And it especially makes a difference if we're using energy efficient lighting such as LED lighting. So that's my next tip, is that when working out the demand for a lighting circuit is to calculate the load in watts and calculate the design current. Now another thing that has a really big effect on the maximum demand is electric showers. Now I've just had a look on one website, and the ratings of the showers vary from 7.5 kilowatts to 10.8 kilowatts. So 7.5 would be 32.6 amps and 10.8 would be 46 amps, which obviously is a lot. And there's no diversity allowable at all for electric showers. So it's really worth bearing in mind, if a customer asks you for an electric shower, it's worth bearing in mind the rating and the effect that that will have on the maximum demand. Now you may be thinking, what if I install a smaller shower and then somebody else comes along at a later date and installs a larger shower? Well, One possible solution to that would be to write on your electrical installation certificate what rating of electric shower you've installed. So instead of writing electric shower on the schedule of test results, you could write 8.5 kilowatt electric shower, and that just makes it much clearer and makes it obvious how you've designed the circuit. Thank you for watching. Please see the link at the end of this video to the other videos on my channel about maximum demand.